Hello, and welcome to this video where we will continue to look and make progress forward from data frameworks to data security control. We have also seen different stages of data and how the controls are applied to it. And when we get now into the core of why we are making data frameworks, data security controls, uh, segregating it into various stages to make sure that the data is protected, both from loss, but also from possibly from intentional leaking, which is a much more difficult thing than preventing the loss. So what is data loss prevention? It's an act or action where the organization want to make sure that the data that goes out from their bounds are protected in a way that they are not lost once it is outside their bounds. You can, for example, imagine that if your organization is storing data on cloud, and if the cloud provider can get hacked, then possibly your data will also be lost in that hack. As I said before, it is important to make distinction between a loss and a leak. A loss can be unintentional, which is probably not under your control, but a leak may or may not be unintentional. It can be an intentional leak. For example, an employee who just got fired or didn't get promoted may try to take the data or the company's secret outside the bounds of the organization to use it for nefarious or any other XYZ purposes. It is also important here that we apply protection based on what is the state, because that it becomes much more implementable and feasible to implement a solution. That's why data at rest, uh, data in transit, and data in use had different mechanisms to get protected. Your data loss prevention strategies for, say, the policies or the frameworks that has been applied should work both at the network, also at the endpoint. For example, the endpoint devices the user is connecting, be it a laptop or a mobile or pads, etc. Now, in general, the application of a loss prevention works in a very architectural manner. Therefore, you have different stages of DLP and you want to tackle different stages differently. So that's why you have first discovery and classification, that you're actually discovering an actual loss happening or probably a leak happening. You classify if this is really a high classified data going out of the network or it is a normal communication. For example, devices connecting to internet. Then based on that discovery and classification, you apply enforcement as to what you want to do if you see a highly classified or secret data. And once you take action, you want to continuously monitor and report it so that false positives or false negatives are taken care. So that's why it's a complete architectural uh, solution which help you implement your policies at right places. You can also apply other tricks in the data loss protection, and that is to do with applying encryption, be it at rest, be it in transit. While encryption in use, as we have seen before, can be a very costly maneuver and has to be done at an absolute need basis. Other aspects like a full disk encryption, link and end-to-end encryption for data in transit are all very well tested, have stayed and stood the test of. What we have seen so far can be very easily applicable to your on-prem data or the data lying at your own data center. But then now the world is evolving into a much more compute hungry aspects of software, which makes holding your own data center maybe not a feasible solution. That's why many organizations are moving their access and data to cloud. And that is where data protection at cloud also becomes an important aspect. As we have seen in the first domain, where we have dealt with the cloud provider and the suppliers, you have a clear risk matrix defined between the provider and the consumer. So just because your data is in the cloud doesn't take any responsibility away from you to protect your data. Of course, the protection of the data, be it a technical or a policy or architectural level, will be aided by the provider, but the responsibility still lies with the consumer. In that sense, for example, in cloud, something called as access security brokers helps to protect your data, and they are basically the DLPs of on-prem or hardened data center concepts, where what they do is that they manage the monitoring aspect, the classification and compliance aspect of your data going out, and if your data is indeed marked as highly secretive or a business secret, then the compliance monitor will kick in and make sure that the data is not leaving the bounds of your organization. Since it's in the cloud, the data has to go outside the bounds of your organization, but then it has to be make sure that it lands where it's supposed to land, protected, and how it's supposed to be protected. There are different mechanisms you can achieve this. For example, you can have a forward proxy, you can have a reverse proxy, you can have API based connection, but these are all technical nitty gritty. The concept remains the same, that the cloud security access broker help you implement a security control, which makes you to adhere to the compliance, the data security aspect, the protection of not losing, the threat protection of not losing your data, and making sure that your data loss prevention application or policies remains in force and workable. With that said, I'll stop here, and I hope to see you in the next session, which will be the last session for this domain. And with that, we will close off the CISSP domain too. But that's for next week. Thank you very much for listening, and I hope to see you in the next session.